In this video, we will study three-phase loads connected in delta and star. For this experiment, we have used lamps to simulate the load. Figure A shows you the connection diagram for star-connected loads. Terminals R2, Y2 and B2 on the load side are shorted to form the neutral point. R, Y and B are the three-phase terminals on the supply side. The supply is rated for 220 volts line to line. We have placed an ammeter A between terminals R and R1 to measure the line current. Terminal Y and Y1 are shorted, B and B1 are shorted. The voltmeter V1 is placed between R1 and Y1 to measure the line-to-line voltage, whereas voltmeter V2 is placed between R1 and Y2 to measure the line-to-neutral voltage. Now, since the line-to-line voltage of the supply is 220 volts, we chose the 300 volt scale for the voltmeter V1, which reads the line-to-line voltage. On the other hand, the line-to-neutral voltage will be around 127-128 volts. Therefore, choosing a scale of 150 volts for the voltmeter V2 will be sufficient. We will power on the circuit and we will take down the readings of these 3 meters, and we will note that the line-to-line voltage will be square root 3 times the line to neutral voltage. Next, we will connect the load in delta by making the connection diagram given in figure B. An ammeter A2 will be placed between R2 and B1 to measure the phase current, whereas ammeter A1 connected between R and R1 will show the line current. The voltmeter V will give the line to line voltage. We will power on the circuit and we will take down the readings, and we will note that the line current will be square root 3 times the phase current. By conducting this experiment, relationships between line quantities and phase quantities for star and delta connection will be verified. In this experiment, we are going to study the characteristic of three-phase load. We will be using lamp loads in this experiment. We will connect the loads first in star connection, and we will see the relationship between line voltage and phase voltage. Then we will connect the lamps in delta and see the relationship between line and phase current. So let's come to this circuit. These are the 3 supply terminals R, Y and B, and from these supply terminals, this where R comes to an ammeter terminal. From the other terminal of this ammeter, this gets connected to the terminal R1 of the load. Now from B terminal of the supply, a wire connects directly to the terminal B1, and similarly from Y, we directly connect Y1 of the load terminal. Now this load is to be connected in star, which is why the points Y2, B2 and R2 are all shorted to form the neutral point. We have connected 2 voltmeters. This voltmeter is connected between terminals Y1 and B1, and therefore this measures the line to line voltage. Whereas this voltmeter is connected between R1 and R2, so this measures the line to neutral or the phase voltage. And this ammeter is connected in series with the line, therefore this reads the line current. So let's start with this experiment. We are switching on this supply. You can see these lamps are glowing, and this voltmeter is reading the line to neutral voltage. So you can take the reading. This voltmeter reads the line to line voltage, and as you can see, this voltmeter reading is about, it's root 3 times the reading of this voltmeter, or in other words, the line to line voltage is square root 3 times the line to neutral voltage. You also need to measure the line to line current, the line current. You can take the reading. So that's about the experiment. So for the star part, let us switch off the supply.
Now we have connected the loads in delta. We have connected a voltmeter to measure the line voltage. We have connected an ammeter to measure the phase current, and we have connected an ammeter to measure the line current. So I will be switching on the supply. So as you can see, the line voltage can be measured from this voltmeter. Phase current can be measured from this ammeter, and the line current can be measured from this ammeter. In this experiment, you need to verify that the line current is √3 times of the phase current. So I will be switching off the supply. That's it about the delta connection.